Hello students, welcome back to my channel once again. This video I'm going to explain the preparation of malonic ester. Under which unit is this malonic ester, students? This is under active methylene compounds, which is in BSc second year semester 3. Okay, so in the previous videos we have seen or we have completed acetoacetic ester preparation and its synthetic applications. Okay, acidic hydrolysis, ketonic hydrolysis, like tautomerism. So everything about this acetoacetic ester we have completed. Next we have in this unit malonic ester, which also contains active methylene group. What is active methylene group, students? What is methylene group? Do you remember? It is a CH2 group. Active methylene group. The methylene group which is present in two high electronegative atoms or groups, we call it as active methylene group. Okay. So now moving on to this malonic ester, look at the structure or the formula. Not actually formula, it is we call this as the structure of malonic ester. It is OC2H5 C double bond O CH2 C double bond O OC2H5. Okay, look here, there is a methylene group in between two carbonyl groups, C double bond O this side, C double bond O this side. So such methylene group we call it as active methylene group. Fine, students? Written? Okay. So next this I just gave two sentences. Malonic ester contains active methylene group, and you know, students, the hydrogens in this methylene group, active methylene group, can be easily removed. How? In the presence of or when we add bases like NaOC2H5, that is sodium ethoxide. That's what I have written 2-3 sentences here. Malonic ester contains active methylene group, one or two hydrogens in methylene group can be easily replaced by alkyl groups in the presence of bases like sodium ethoxide, that is NaOC2H5. Okay. Now look at the preparation of malonic ester. So malonic ester can be prepared from acetic acid. What is the formula of acetic acid, students? CH3COOH. Malonic ester can be prepared from acetic acid. Okay, right. Now taking acetic acid, look here, CH3COOH. This has one COOH group, therefore it is called as a monocarboxylic acid. Okay, students. So take CH3COOH, write down, add Cl2 in the presence of red phosphorus. So what happens? One of the hydrogens of this methyl group and one Cl comes out as HCl. So I have written minus HCl. Okay, students. So one more Cl is here. So it will be replaced in the presence of one of the hydrogens which is removed. So what do we get here? Look here, CH2COOH. Now there is no H here. In the place of H, Cl is replaced. So chloroacetic acid. I have written the name here, students. Next, after chloroacetic acid, adding K2CO3. What is K2CO3, students? Potassium carbonate. So potassium carbonate. What are being eliminated? Carbon dioxide and KOH. Okay. Carbon dioxide and KOH. What is this KOH? Potassium hydroxide. So what do we get next? Cl, CH2, COOK. So this H is coming out as KOH. From K to CO3, students. Okay. 1K 1O and H, KOH, and remaining CO2 coming out as carbon dioxide. So 1K is replacing hydrogen over here. So we get Cl, CH2, COOK. What is this called as? Potassium chloroacetate. Potassium chloroacetate. Next, treating this with KCl, potassium cyanide. Okay, so K and this Cl will come out as KCl, and in the place of Cl, Cn will be replaced. So here we are getting CnCH2 COOK. Okay, so what is this called as? Potassium cyanoacetate. Here it is potassium chloroacetate. Here it is potassium cyanoacetate. Next, on hydrolysis, in the presence of HCl, what happens? Minus KCl. That means KCl will be coming out, students, and this K will not be there. Here we will be getting a hydrogen and Cn group will be hydrolyzed, and here also we will be getting, this will be getting a COOH group. This compound will be getting a COOH group. I will show you the next compound. Look here, CH2 COOH COOH. Okay, CH2 COOH, which is nothing but called as, students, malonic acid. Okay, now this malonic acid, when treated with 2C2H5OH, ethanol or ethyl alcohol, in the presence of dry HCl, 2 water molecules will be eliminated, and here we will be getting OC2H5. Okay, and and also this hydrogen will be replaced by OC2H5. Look here, final compound OC2H5, C double bond O. Write a bond over here. Okay, CH2, C double bond O, OC2H5. This is nothing but our malonic ester, students. Okay, I will show you again, starting with the acetic acid treated with Cl2 in the presence of red phosphorus minus HCl. That means here one of the hydrogens is coming out with Cl as HCl. Now Cl is replacing hydrogen, chloroacetic acid. Next K2CO3, CO2 and KOH. So this H will be replaced by K, called as potassium chloroacetate. Next KCN. So minus this Cl and K will be coming out as KCl. Next here it will be replaced by Cn, potassium cyanoacetate. Next, on hydrolysis in the presence of HCl, so KCl will be coming out. Okay, so look here, students, COOK, K and Cl, KCl will be coming out. This H will be replacing potassium, and Cn on hydrolysis will be converted into COOH group, from which we are getting malonic acid, COOH, CH2, COOH here. Clear? Next, on treatment with ethyl alcohol in the presence of dry HCl, 2 water molecules will be eliminated, and finally we are getting malonic ester. This is how malonic ester is prepared from acetic acid, students. So this is all about malonic ester structure, its active methylene group, and also preparation, students. Those who are watching for the first time, please subscribe the channel and like the video and share with your friends. Please don't forget to like the video, students. Okay, so next we will be learning about the synthetic applications of malonic ester. So what all compounds can be prepared from malonic ester, all this we will be learning in the coming videos. Okay, so stay tuned, students. Meet you in the next video with a new topic. Take care.